All right, so first problem's right there in the center. So we have kind of the 4 boxes. It used to work out great because we had 4 methods, but I didn't teach you that completing the square, so that kind of takes that method off of there. The first thing is, how do you determine whether or not it factors? The discriminants. So since we have this extra box down here, let's use this box to actually find our discriminant. What does the discriminant tell us? You said I can use it to tell if it factors. How do I know if it factors? Good. So maybe make a note to yourself. If perfect square or 0, it will factor. So it's kind of nice to know from the beginning, like, if it'll factor or not. Sometimes to play around with the numbers and guess and check, and like, sometimes you know it factors and you still can't figure it out. So if we figure this part out first, it'll help us determine if it factors or not. All right, so before I can do the discriminants, what do I have to do with that problem? I agree, but what do I have to do with this first? Equal it to 0. Yeah. All right, so let's go ahead and set this equal to 0. So I'll have to subtract the 57. So 2x squared minus, is that 72? Equals 0. Okay. So to use the discriminant, the problem has to be equal to 0. Factoring, equal to 0. Quadratic formula, equal to 0. Square root? No, this is where you isolate x squared or parentheses squared. Okay, just so we're clear on all of that. The only time you're not setting it equal to 0 is the square root method. All right, so let's go ahead and figure out the discriminant. Dylan said something about plugging things in. Plugging into what? What's the formula for your discriminant? Good. It's the part that's under the radical in your quadratic formula. So that's what you use to find, that's the discriminant. Okay, so looking here, what's my b value? 0, because there isn't one. So 0 squared minus 4 times, what's the a? 2 times the c, negative 72. Now, if this equals out to be 0 or a perfect square, then I know it factors. So we just type it in. 0 squared minus 4 times 2 times negative 72. Try again. There you go. That equals 576. Is 576 a perfect square? Yeah, it is. So since this is a perfect square, we know that this problem will factor. Now, is it possible that you could have just looked at that problem and known that it factored? Or some of you probably maybe bright enough that could have figured that out? Yes. Right now you're all not looking at me like I'm crazy, so maybe not somebody in here, but somebody can look at that and know. All right. There's no b value. So what's the only type of factoring that could be? What's my favorite? Difference of squares? You guys with me on that? The way it sits, they're not both squares. Is there a GCF in this? Yeah, so we know it factors. And it's okay, if you don't recognize it, that's perfectly fine. That's why we have discriminant. That's why it helps you figure that out. So it's already set equal to 0. 2 is my GCF, so I'm going to pull out a 2. So I'm left with x squared minus 36. How does that factor? Good. Yeah, remember difference of squares, those are the easy ones, right? 1 plus, 1 minus, square root of each. Square root of x squared is x, square root of 36, 6. All right, how do you finish solving? Ben? Set them equal to 0, not x. I knew what you meant. Does baby brother give me an answer? No, there's no x there. He does not affect my answer. So if I solve this, I get x equals -6. Add 6 to the other side, x equals 6. I have my 2 answers. Did you know you were going to have 2 answers before you started? Yeah, because it's x squared, so I know it's 2 answers. All right, great. Okay, square root method. How do you tell if you can use the square root method or not? There's no bx. So what's the easiest option to determine? A square root method. You should be able to look at it and be like, oh, look, there's no bx. I can use the square root method. Okay? So I'll go ahead and write it where I have it here. I have 2x squared minus 72 equals 0. Do we want this equal to 0? No. We need to isolate the square term. Add 72 to the other side. Can I take the square root right now? Nope. Some of you like to, but don't. Divide them by 2. And we get x squared equals 36. Take the square root. So x equals plus or minus 6. Thank you. Holy crap, I got the same answer over here. Mind blown? It shouldn't be. It's the same question, right? Every year there's always one student that's like, oh my God, you got the same thing. I solved the same problem. I should have the same answer. I should. Yeah. How about quadratic formula? Can I use that? Yeah. Always. Any quadratic, you bet. So, okay. Let's start out. This again is one that you want equal to 0. Everything's equal to 0 except the square root method. All right. Do I have to take out a GCF or anything on quadratic formula? No. We can just plug everything in. So x equals negative b. What's my b value? 0. Please don't write negative 0. You know that's not a real thing, right? I will tell you once, I have a picture of it somewhere. I'll find it. I was watching the news once, and they were showing like the weather map and like current temperatures like across, northern part of Ohio, and there was a -0 on their weather map. Yeah, I paused my TV and literally took a picture. I was appalled by it. -0 is not a thing. All right, 0 plus or minus square root b squared. So 0 squared minus 4 times a times c all over 2 times a, which is 2. Did you already do the math to figure out what that number is under the radical? Yeah, you can do it over here. All right, so x equals 0 plus or minus the square root of 576 over 4. What is the square root of 576? 24. So 0 plus or minus 24 over 4. Can I divide all 3 numbers? 0 divided by anything is still 0. You know that, right? So now let me ask again. Can I divide all 3 numbers? I can divide them all by 4. What's 0 divided by 4? 0. Plus or minus 24 divided by 4. 6. 4 divided by 4 is 1. Do I need to divide by 1? No. All right, what's 0 plus 6? 6. What's 0 minus 6? -6. Whew, I got the same answer. Now, just out of my own sheer curiosity, that problem is one of those rare ones that I could actually solve in all 3 methods. How many of you prefer factoring on those 3 methods for this problem? Okay, how many of you prefer the square root method? And how many prefer quadratic formula? Wow, you guys are pretty evenly split between the 3 methods. Me personally, a problem like this, I would go square root method. It's just my own personal preference. All right. Can you, sorry, that was from my other class, I was throwing stuff in here. Can you, at any point, do every single problem all 3 ways? Is it possible I can only do it one way? It's possible. Is it possible it doesn't factor? Yeah. Is it possible it has a bx, so I can't use a square root? Yeah. It's possible all you can do is quadratic formula. Is it possible I can factor and square roots? Yeah. We just did, right? I factored and I had square root method. Is it possible that I can use the quadratic formula only? Yes. Is it possible I can factor only? No, because that works on everything. Is it possible I can use a square root method only? No. Right. Quadratic formula works on everything. Okay. All right. So next problem. X squared minus 4x minus 45 equals 0. So it's already said equal to 0. That's good. Let's go ahead and just jump right to the discriminant. That will tell us whether or not it factors. So again, that's your b squared minus 4ac. What's my b value? Negative 4 squared minus 4 times my a. Somebody besides Dylan can talk to me, although I really appreciate it, Dylan. And my c. Thank you. All right, see what we got. What do we get? This is the interactive part of class where you guys try things, not just sit there and stare at me. Try again. Say that again. Thank you. 196. Double check. Did you put parentheses around negative 4? Did you make sure your 45 was negative? You should get 196. If you didn't, please type it in again so we can figure out what happened. Did you find it? Which again, guys, that's why you practice this. Because if you don't, you may forget things like that. But if we practice, we can kind of catch those errors early. All right. So is 196 a perfect square? Yeah. Yeah, it's a perfect square. Yay, perfect square. That means it will factor. Okay, so let's come up here. So x squared minus 4x minus 45. Is there a GCF? Nope. So no GCF. So I'm going to go ahead and open up my parentheses. What are my signs? The last one is negative. Plus and minus. Options for A. 1 and 1. So I have 1x and 1x. Options for C. I'm going to make my nice orderly list. So I have 1 and 45, 3 and 15, and 5 and 9. And which option is it going to be then? 5 and 9. Which one's negative? The 9's going to have to be negative. Yeah, we want a negative 4. Again, remember, if we're a little rusty, we would check, right? Inside and outside to make sure that gives me what I wanted. Do you remember this? I know we're a little rusty on the factoring. Okay. So just make sure you're checking. Don't assume that you're the world's best guesser and just put them in there and not check them. All right. From there, set each factor equal to 0. Again, if you were at a place where you can do this in your head, feel free. We'll go ahead and solve. So x equals negative 5 and x equals 9. Is factoring coming back? I know we've kind of focused on the other two for a little while here. What about square root method? Why? Good. It has a bx term. All right. It has a bx term, which means I can't use the square root method. Can I use the quadratic formula? Yeah. All right. So plug it in here. So x equals negative b. Now, since my b is already negative 4, what's negative b? Positive 4. Thank you. Plus or minus, it's going to be the square root of 196. You guys okay if I kind of jump to that since we just did it right here? Over 2a. So 2 times 1. What is the square root of 196? Ooh, you guys are ready to answer that one. All right. And can I divide all three numbers? Yes, I can divide them all by 2. So we're going to get 2 plus or minus 7 over 1. Do I need it? No. All right, well, what's 2 plus 7? What's 2 minus 7? And that's the same answer I got over here. So is it possible when you're taking your test on the first 3 sections, when I specify which method to use, could you use a different method to check your work? Yeah, you could. And I'm okay with that. I've had students do that. I've had students go through and redo every factoring problem with the quadratic formula because they were not comfortable factoring and they just want to make sure it worked. Totally up to you guys. How are we feeling so far? Ready for the test? You want to take it now? Some of you probably would. All right. 2x squared plus 13x plus 21 equals 0. It's already said equal to 0, so that's good. All right, what should we do first? Let's do the discriminant. Let's check and see if it'll factor. So my b value is 13 squared minus 4 times 2 times 21 and what do we get? 1. Is 1 a perfect square? I heard no, I heard yes. What's the square root of 1? 1. Is it a perfect square? Yes. All right, so since it's a perfect square, what's that tell me? It factors. Had it not been a perfect square, I'd have drawn a big old X through this box, and I would not have factored. Okay, but it is, so it will factor. So let's go ahead and factor. So we have 2x squared plus 13x plus 21 equals 0. Is there a GCF? No. Do you have a pencil? Okay, so there's pencils in the bucket if you need one. You're more than welcome to them. All right, so no GCF. Okay, so let's go ahead and set up our parentheses. Last one is positive. Are they both plus or both minus? Both plus. There's no minuses anywhere. All right, options for A, 1 and 2. Okay, so I'm going to have 1x and 2x. Options for C. Anything besides 1 and 21? 3 and 7. Good. All right, so we got an option. Do you want to go 1 and 21 or 3 and 7? In that order, 3 and 7? 7, 3? I heard it doesn't matter. Well, let's check. Does it matter? It does matter. If I check this, I get 14x and 3x. Will that make 13x? No. Are you okay? The only time it really doesn't matter is if your numbers with the x's are the same, then it wouldn't matter. All right, so since that didn't work, your next choice should be to just flip-flop these and then check that. So that gives me 6x and 7x. Will that make 13x? Yeah, so then that's how it factors. All right, set each factor equal to 0. So x plus 3 equals 0. 2x plus 7 equals 0. And we solve. So x equals negative 3. Here it's subtract 7. And then divide by 2. So x equals what? What would you write? What would I expect that you write for your answer on this? Yeah, negative 7 over 2. It does not simplify. Please don't turn it into a mixed number or a decimal. Just leave it 7 over 2. Doesn't exist, so knock yourself out. All right, square root method. Why not? It's got to be x. Can't use that. Quadratic formula? Yep, always can. All right, so let's go through here. So x equals negative b. It's going to make that negative 13 plus or minus square root of 1 over 2 times a. Again, I already did my discriminant, so I just kind of jumped a step there. What's the square root of 1? 1. So negative 13 plus or minus 1 over 4. Can all three numbers be divided by something? No. But are they like terms? Yeah, they're all just numbers. The way to tell here, guys, if there's an I or a radical, then you're done. They're not like terms. But if there's no I, there's no radical, that means they're all like terms. I can put them together. So on the top, what is negative 13 plus 1? Is negative 12 over 4. And negative 12 over 4 is negative 3. Then negative 13 minus 1, negative 14 over 4, which you would simplify, negative 7 over 2. So again, factoring or quadratic formula, wherever you're more comfortable. Personally, I'm faster at factoring, so that's where I would go. I can do that without a calculator. All right, you have one more on there, right? That is for you guys to try on your own. So take a few minutes, try that last one on your own. All right, first thing, it's already set equal to 0. What should you do first? Should you jump right to factoring and try to factor it? And I saw probably at least 3 people who did. What did we do first on the first 3 problems we did today? We found the discriminant. Let's find the discriminant. All right, and that again is your b squared minus 4ac. It's the part underneath the radical. So b squared would be 8 squared minus 4 times negative 2 times negative 20. And what do you get? Is negative 96 a perfect square? No. So if it is not a perfect square, what does that mean about factoring? It won't factor. Some of you wasted the entire time I gave you just now to work trying to factor that. Pretty sure the last 3 problems, we did discriminant first to determine whether or not it factored. That's not a perfect square. It won't factor. Moving on. I don't even have to attempt it. Ben? Right, because the discriminant goes where? Underneath the radical? And if you have a negative under the radical, what's that mean about your answer? It's imaginary. We don't factor imaginary things. Be thankful we don't. That would be really, really ugly if we tried. All right, so we know it doesn't factor. Square root method. I had other people doing the square root method on this. It's got to be x. You can't. You can't do this. How many times have we talked about if it has to be x, you can't use the square root method? I need some of you to understand where I'm coming from, my frustration. From day one, if it has to be x, you can't use the square root method. And I got people trying to do square root method on that. Okay? Got to pay attention, guys. Quadratic formula. Yes. It works on all of them. Did you do this? What? Did you do this?
First thing I did.
And then you still tried to factor it, even though you got that to be a negative 96? Well, we talked about just today, though, right? Like, is it possible that you can only use quadratic formula? Yeah. Is it possible to have 2 of them not? Just for future reference? You betcha. It happens quite often. Yep. All right, so we got to use like the knowledge we do have. And I'm not picking on you by any stretch, because I'm glad you brought it up. But use the knowledge you have, right? We've learned if this is not a perfect square or 0, it doesn't factor. If it has a bx, you can't use that method. So obviously we can't do either of those. Quadratic formula, that one works. So negative b is negative 8 plus or minus square roots. If you moved everything, I know like Quinn asked if you could move everything and change all the signs. Yes, totally fine. Your work may differ slightly, but we should still have the same answer. Okay. This was negative 96, because we already did that. All over to A. Again, yours will look a little different until the very end. Now, negative 96 is that we already established it's not perfect. So what should we do with it? To a factor tree. I still see some of you trying to divide all of these numbers. You're like, look, I'm doing all 3 numbers. not the one under the radical. The only way they come out of here is a factor tree and having a pair, okay? The three numbers I'm referring to are the one in front, the one right in front of the radical, and whatever that bottom number ends up being. So this is going to be, what, 3 and 32, 2 and 16, 4 and 4, 2 and 2. So we got a pair of 2s and a pair of 2s, which gives me 4. Don't forget your I. Good. And a radical, 3 times 2 is 6. Some of you walking around either had a 3 under there or a 2 under there. I don't know if you just lost one of your own numbers in your work. All right. Now when I look at, can all three numbers, these are the numbers. It's never the one under the radical, okay? Never dividing that one. That one's only factor tree. Quinn? Right.
Yep. They're all still divisible, which gives you all this for -1, I think.
If I have a negative on top and a negative on bottom,
no.
What's two negatives make? Positive.
Okay, so
yeah.
That would screw me up. So we fly.
Which is totally fine. Yep, totally fine. So dividing them all by 4, we get 2 plus or minus I, or 1I, radical 6 over 1, but I don't really need the over 1 part. So 2 plus or minus I radical 6. Different way. You erased it. Oh, you took out a GCF first. Yep, still work. But you don't have to. But yes, it does work if you do. Yeah, Ben. That just goes with anytime you're multiplying and dividing. You can always multiply and divide if they're not alike. You can't add or subtract. Think about what multiplying actually means. What does it mean to multiply something? It's repeated adding, right? So if I said, it's a good question because people always question that. So if I would ask you to multiply 2 times 3i, one's imaginary, one's not. Really what that means is I have 3i plus 3i. It means I have 2 of them, which would give you 6i. The same way if I multiply 2 times 3i, 2 times 3 is 6i. So multiplying, it really just means it's repeated adding. That's all that really means. Whereas if I had 2 plus 3i, that's like me saying, hey, look, I got 2 apples and 3 baseball bats. What do you got? You wouldn't say 5 apple baseball bats, right? Like that doesn't make any sense. You wouldn't actually put them together. Okay, so this we can't, so they're not alike. It's not like the same objects I can group together. Multiplying really means repeated addition, so technically then they are the same. So it works. Quinn?
So it's like, I'm just restating. It's like, as opposed to having, when you do 2 times 3i, you're saying you have 2 groups of 3i.
Yes.
2 plus 3i, you're adding 2 to 3i.
Correct. Yep. No, perfect. You said it perfectly. All right, so let's talk on this test for next week, on that back page. What's your game plan going in? You have to use each method twice. Which methods should you look for first? What do you think? Discriminant first? Okay. Is that everyone's first choice? I would use the square root method first. Reason being, is it possible that you can factor it and square root method? The very first one we did today, right? What if I only put 2 on there that you use the square root method on? You don't want to accidentally factor that one first because then it's taken off your list. All right, so what I would do, I agree with the discriminant part, but this is why we talk about it. Because, yeah, if I only give you 2 that you can use the square root method on, and one of them also happens to factor, you don't want to factor it first because then you've just taken one of them off the table that you need. So first, I would do the square root method. And those should be easy to tell. How do you know if you can use the square root method? No bx. Is that equal to 0 or no? No. Isolate x squared or parentheses. squared. All right, then what should you do? Then I would do the discriminant. You're going to have 4 problems left at that point. Look for the discriminant. All right, and again, that's b squared minus 4ac. What am I looking for when I do this? Good. If it's 0 or perfect square, factor. Okay, so I would find those two, and then last, use quadratic formula. So that back page, that's kind of your game plan. To find the 2 that you can use square root method on, do those 2. Then you have 4 problems left. Check those discriminants. As soon as you find a perfect square on one, factor it. Go back through the next 3, find one that's got a perfect square on it for discriminant, factor it. And then the other 2, quadratic formula. Okay, that way we make sure we hit the ones that you need for all of those. Because chances are I'm going to only have 2 that will possibly do the square root method on. Questions there? We feeling a little better about all this, I hope?